Good morning, everyone. Welcome again to my YouTube channel and welcome to Genius Squad Tutorial YouTube channel. In this video, we'll try to be explaining stoichiometric calculation in thermodynamic reactions, Hess Law, and standard heat of formation. But before we start, let's understand what they are trying to explain. In a thermodynamic reaction is a particular reaction that must have what a phase changes and a specific what and a specific heat of enthalpy. After you see a particular reaction, there must be each of the phase there. Maybe it's liquid, gas, or solid. And also at the end of that reaction, you must see something like changing H is equals to minus K equal specific heat joules. Are you getting it? So that's what we mean by what thermodynamic reaction. And in thermodynamic reaction, we have two specific rules in thermodynamic reaction. When you multiply any thermodynamic reaction by any factor, the delta H must also be multiplied by the same factor. When you reverse any thermodynamic reaction, the delta H signs must also be reversed. And also, let me try to explain what S law is trying to say. S law is trying to say that no matter how much the steps is required for a particular reactant to form a particular product, the total heat of enthalpy depends on the summation of all the heats of that particular reaction. Let's take for an example. Maybe a particular reaction has about 4 to 5 steps. You are not S law is not really concerned about the number of steps, just the addition of all the heat of formation of that particular reaction. Then concerning the standard heat of formation, how will you calculate the standard heat of formation? For you to calculate the standard heat of formation, they will give you the standard heat of formation of all the constituents present in the specific reaction. Just like, for example, now, if you want to calculate the standard heat of formation for the combustion of methane, during the process of combustion of methane, you have your methane, you have your oxygen, you have your CO2, and you have water, right? So that will provide you with the heat of formation of all these four things. If you don't want to calculate the heat of formation of all the reaction, then you say standard heat of formation of the product minus standard heat of formation of the reactant. So just follow this video as I'll be explaining some key core aspects that you have to understand. First, let's try to explain the stoichiometric calculation involved with thermodynamic reaction. We were trying to explain this particular concept. They said using the following thermodynamic equation, calculate the amount of what heat required to decompose 4 moles of sodium of ammonium chloride of ammonium chloride. To decompose 4 moles of ammonium chloride, meaning that before you form this particular 4 moles of ammonium chloride, we have what NaCl is being given, is being produced. That's the initial equation. In the first equation that will be given, NaCl will be produced. But if you not, the last cell will decompose. So automatically you have to reverse that particular equation. And initially our what? Our delta H is equals to plus 176. Sorry, minus 176 kilojoules. So you have to reverse the equation, because in the control equation, what you were given is what NHCl is what NH4Cl is formed. But in the question says what we should calculate the amount of moles, the amount of heat required to decompose 4 moles of NaCl. So we have to reverse. So when we reverse the equation, our delta H will now be equals what minus 176 kilojoules plus 176, because initially we have minus, but because we reversed, then we have minus 176. So you cannot go back to this equation. You cannot go back to your reverse equation and say if 1 moles of NH4Cl, if 1 moles of NH4Cl, if 1 moles of NH4Cl can give you what? Can give you, it has been reversed, plus 176 kilojoules. Then 4 moles of what? 4 moles of NH4Cl will now give what? 4 moles will now give you X. So at the end of the day, then your X will now be equals to what? 176 times what? Times 4, in which we have what? So that's plus 704 kilojoule. So to solve this particular questions next time, you have to first check what exactly is the statement saying. What exactly is the main concern of the statement? If they said what decomposing, meaning that was something has to break down, and in the control equation you were given, maybe that particular something is formed, so we have to like reverse that particular equation. So another one I'm trying to explain though is the S law. Anytime we're given an S law, we'll be given a particular control reaction as well. We'll be given a control reaction. Let's take an example now. This is my control reaction. Maybe 2A plus what plus 3B to give me what? To give me 4C. This is my control reaction. I was now asked to calculate the delta H of this particular reaction. But this is a control reaction. They will not give me some reactions as well. They will not give me a reaction. Maybe A plus B to give what? To give C. Then this one is what? Maybe change in H equals what? 176 kilojoules. Then again, C plus B to give D. Then this one is what? Maybe this one is changing H to be equal to what? 28 kilojoules. Then we have what? We have B plus D, B plus C to give what? To give D again. Then we have what? We have change in H to equals what? 20 kilojoules. So the next thing that we should look for I should look for the change in H in this particular reaction. First, what am I going to do is that this is my control reaction. This is the reaction that I'm really concerned with. Here, my A is at the reactant side, right? So let me start analyzing the steps one by one. Here, my A is at the product side, is at the reactant side. So automatically, what I just have to do is to multiply the factor of this delta H by what? By 2. Because we have 2A in my what? In my control reaction. So the delta H for what? The delta H for my A, for my first one was 2 times what? 2 times 176. 2 times 176. We have 352 kilojoules. I'm not yet done. The on another composition of the reaction, we have 3B. If you check my B is at the reactant side here. Same thing as this one is at the reactant. So I don't need of reversing the equation. But what I just did is that I just have to multiply this particular delta H I'm given by what? By 3. So I know that my delta H will now be equal to what? 3 times what? 28, which will now be equal to 84. That's 84 kilojoule. 84 kilojoule. To the last one, if you check, my C is here. My C is at the what? Is at the product side. But in this particular reaction, my C is at the reactant side. So automatically, I'm going to reverse this particular reaction so that my delta H is going to have a negative. So once my delta H have a negative, and I'm still going to multiply this factor by 4, because in my control reaction, I have 4 moles of what? 4 moles of constituent C. So I'm going to have my delta H for the other one now because 4 times what? Minus 20 kilojoule. Then I'm going to have what? 4 times. That's minus 80 kilojoule. So at the end of the day, I cannot say that my delta H for this reaction, is what? Delta H will now be equal to 352 kilojoule plus 84 kilojoules plus into bracket minus 80 kilojoules. So at the end of it, I'm going to, most of you don't watch very well when you're doing calculations. As much as this particular concept is very simple, you can mix it up. So you have to understand, break it down very well. So 352 plus 84, this one times this one will be minus, that's 80. Then I'm going to have my delta H will not be equal to 352. 352 plus 84 minus 80. I'm going to have 356 kilojoules. So my delta H for that particular reaction is what? Is 356 kilojoules. So that's what Hess Law is trying to talk about. We are not really concerned about the steps, but we are only concerned about the addition or summation of all the heat of reaction of each particular steps. So let's try to explain what we mean by the heat of formation as well. In a particular reaction, anytime you are in heat of formation, you will be given the enthalpy of each of the constituents present in that particular reaction. let's take for an example. If I have what? If I have 2C plus O2 to give me 2CO2, I'll be given the enthalpy of this one. I'll be given the enthalpy of this one. I'll be given the enthalpy of this one. So for me to now calculate my standard heat of formation, I will not say my heat of formation will not be equal to heat of formation of the product, heat of formation of the product minus heat of formation of the what? Of the reactant. So automatically I have to first resolve this one first. So I might be given my what? The heat of formation of this carbon to be equal to what? To be equal to maybe delta H will be equal to plus 76 kilojoule. It's an hypothetical, and that is not the exact value. Then my oxygen, anytime you see oxygen like this, or maybe generally gas, their delta H is always zero. You might not be given in exams, but note that their delta H is always equal to zero. Any particular gas in its state is equal to zero. So to my delta H for oxygen, this one is for carbon, will be equal to 0 kilojoules. Then they will give me that of CO2 as well. Then my CO2, my delta H, heat of formation of CO2 will be equal to, because let's take maybe plus 183 kilojoules. But note here I have 2 moles of what? I have 2 moles of my carbon, so I have to multiply this one by 2. So give me that 76 times 2. Then we'll have what? 150 what? 152. This one is what? Is 0. Then this one is what? Then I'm going to multiply it by 2 because I'm having 2 moles of CO2. Then I'm going to like 2 times 133. Then I'm going to have 266. So I'm going to have 266 kilojoules. Am I communicating? So after I've already gotten all these particular concepts, then I'm not going to go back to my formula that said standard heat of formation is equal to the heat of the product minus heat of the reactant. This is the product, right? And this is the reactant. So I'm not going to go to my formula. Oh, I've already wrote it off. But I think in the video, just try to watch the values I got and try to do the calculations. So my standard heat of formation will not be equal to heat of is the formation of the product. What is the product? What is the product? The product is what? Is this one that, because that's 266 minus what? Heat of the reactant. But here minus this one of the reactant. I already gotten this one to be equal to, that's 76 times what? 76 times 2. So I go 152 minus 152 plus what? Plus into bracket 0, because all those ones that are the reactants, you have to add them together. And all those ones that are the product, you have to add them together. So my delta H, my heat of formation will not be 266 minus what? Minus 52. So at the end of the day, I will add 266 minus 62 minus 152. Sorry, 266 minus 152. So my delta H for that particular reaction is 1114 kilojoule. So please, and this science is very, very what? They are very, very important. So that is the analogy. That's everything that you have to understand about thermodynamic reaction, Hess law, and standard heat of formation. They are very, 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 very simple. And also, let me try to revert to something. In as much as they might, okay, maybe you are comparing 2 moles together now. Okay, if 1 moles of what? If 1 moles of NH4Cl can give about plus 176 kilojoules, then you are comparing in terms of, that's what we call stoichiometric mole comparison. We're not saying that 4 moles will not give X. You have to compare the moles. But here, instead of them giving you moles, they cannot give you in form of a mass. They can give you in form of a mass. So automatically, you know that your mole is equals to what? Is equals to reacting mass over what? Reacting mass over molar mass. So you have to get the molar mass of this NH4Cl. You now divide the reacting mass. The mass that you were given is the reacting mass. You will now divide it by the molar mass again to get what? To get the moles. And also, they might also ask you to balance it in terms of what? In terms of mass comparison. So that is all you have to do. Just know that what? In a thermodynamic reaction, anytime you are reversing the equation, the sign must also be changed. Anytime you are multiplying the equation by any factor, your delta H must also be reversed by that same particular factor. So thank you very much for watching. Thank you so much. Please subscribe like, and comment. See me in the next video.